bienvenidos a Conversando Libertad por Palabra Pública. Antes de comenzar, los quiero invitar a que se suscriban a nuestro canal, le den like a la campanita y compartan nuestro contenido. También los quiero invitar a que sigan Palabra Pública Shop con Luis Marchena desde Brasil y Lenin Fernández desde Chile, un programa donde comentan algunas noticias importantes de la semana sobre política, economía, entre otros temas, en una conversación relajada y amena con un poco de humor. También los invito a que estén atentos a nuestras próximas entrevistas con Natalia Melnick, Axel Kaiser, Brian Kaplan e hijos. Y bueno, el programa de hoy estará súper entretenido e interesante. Nos acompaña el día de hoy el profesor Avi Loeb, exdirector del Departamento de Astronomía de Harvard y actual profesor de ciencias en esa universidad, autor de más de 500 papers y autor de un libro que se está convirtiendo en el más vendido de Amazon. Me refiero a Extraterrestrial. Y de eso y mucho más vamos a estar hablando el día de hoy. Profesor Avi Loeb, welcome to Palabra Pública.
Thank you for having me.
Well, first of all, it's an honor having you here today with us. We're super excited you're here today to discuss and talk about science, astronomy, and the implications of Oumuamua. I know you are a celebrity today, probably been contacted by filmmakers and producers from Hollywood. I'm sure your waiting list is vast, so I really appreciate you are with us today. But before you address your book on Oumuamua, which is hard to say, Oumuamua, I'd like to explore a little bit the current state of science. I'd like to start mentioning two books that were important for me, and I think your book fits like the natural next chapter of them. That's what I think. I'm thinking about Carl Sagan, which I think inspired all of us when we were young. And I remember reading his book Cosmos and getting crazy with the pictures and description on it. And since then, I got an idea stuck in my mind that Sagan wrote in that book. In the first chapter, he said something like, we grow up in isolation, only slowly do we teach ourselves the cosmos. I think you work with a 21 centimeter cosmology, the Black Hole Initiative, even the Perseverance rover, and many other breakthroughs are in the direction of teaching us and unveiling the cosmos for us. And the second book I want to mention is The Atom by Lauren Krauss, where he speaks about what happened within the first second after the Big Bang. And I know there is math and theories and experiments involved in those books and papers, but still, we are talking about moments right after the Big Bang. It sounds very awesome, a little bit like science fiction. But as far as I'm concerned, it's scientifically accepted. You can tell me later about it. That's why when I read an article written about you in the Scientific American magazine, it was written by Lee Billings, and I feel a little bit worried about what you were saying. For instance, you argue that too many scientists are now mostly motivated by ego. They treat science as a monologue about themselves rather than a dialogue with nature. You also talk about echo chambers, and you state that you can never tell in advance when you work or if you're working in the frontier what is right, what is the right path forward. The only way to learn it is by getting feedback from experiment. And I think that's the keynote here, because learning by getting feedback from the experiment sometimes imply also getting unexpected results. Or in the process of our research, for example, we can discover what have never been discovered or see what have never been seen. Somehow fear that no seems to be part of our nature. So don't you think part of the criticism you receive, like you only found a peculiar object, an interstellar object, exotic, but still a rock, don't you think that such rejection a priori is based on this fear about finding something new? Isn't science about it?
Well, that's an excellent question. Indeed, there was a lecture about this object, Oumuamua, that we will discuss. And when I left the room, together with me was a colleague of mine that worked on rocks from the solar system for several decades. And he said, this object is so weird, I wish it never existed. And to me, that was a contradiction of what our role as scientists is, in the sense of actually welcoming evidence that doesn't line up with what we expected, because that's an opportunity for us to learn something new. Science is a learning experience. It should be exciting. It's not supposed to be boring, reflecting things we already know from the past. And there is nothing more exciting than looking for potential signatures of other civilizations in space. This is a question the public is extremely interested in, but currently the scientific community is not funding the search for technological relics in space, and or funding it at a very low level. And that is my main concern. Now, just speaking in general, when we are born into this world, we are put on a stage, just like in a play, and we're not given any script. We don't know what we are doing, what our role is. And the purpose of science, in my view, is to tell us more about the stage, who else is out there. So the most fundamental question is, are there other actors? Are there other kids on our block, in our neighborhood? And that is the question that interests me the most, because it may well be that we are not the smartest kid on the block and we can learn from them. And to me, it's a question that will have a big impact on society if we find the answer to. And I'm just dismayed that the scientific community does not put it as a high priority right now. I think it should be part of the mainstream, but it's being ridiculed and it's not taken seriously. And the argument often made is that extraordinary claims, like a claim that there is another civilization, requires extraordinary evidence. And in my view, extraordinary conservatism leads to extraordinary ignorance, because if you're not looking, if you're not searching, just because you shy away from these questions, if there is no money invested in the search and people are ridiculed when they discuss it, then obviously you will not find anything. It's a self-fulfilling prophecy. And in order for us to make progress, we need to change this culture, to invest funds in the search and to have talented people discuss this search. And that it's often being said that it's controversial subject, so scientists do not want to discuss it, the search for other civilizations. But if you go back in history, there were people claiming that the human body has a soul and therefore anatomy should not be pursued. And just think about a situation where scientists would say the human body is a controversial subject. Some people claim that it has a soul and other people deny that. And we don't want to deal with that controversy. And therefore, anatomy would not be pursued. So what would happen with modern medicine if that were the case? I think that science has an obligation to attend to questions that are of great interest to the public and importance to the public, using the scientific method, applying the instruments we have and trying to answer those questions. And since the public funds science, we have an obligation to address these questions rather than shy away from them.
Mm-hmm. It's like statistically, if you try to find something, probably you're going to get it, at least a bit of what it is. But if you don't try to find, probably you're going to get zero.
Right. Yes, exactly. If you're not ready to discover new things, you will never find them. That's my main point. And it's just like stepping on the grass and then saying, look, the grass doesn't grow. So it's a self-fulfilling prophecy. And, I remember when my daughters were very young and they stayed at home, and at that point they thought that they're the smartest kid on the block, they're the smartest in the world. But once we took them to the kindergarten, they found other kids and recognized that that's not the case. And of course, it was a psychological shock for them. And they would have much rather preferred to stay at home and maintain the illusion. But I think that it's the duty of science to inform us about the environment so that we cope with it in a better way.
Yeah, Very nice use the illusion word there. And Ignacio have a question.
Well, yeah, as you were just talking about so many different interesting things, there are so many different sentences, words, stories that you talked about in your book that actually just have my mind just going everywhere. And I'm just getting excited, but I'm just going to come back to the topic that I was going to talk about. Well, first and foremost, of course, Francisco already said it, but thank you so much for being with us today, Professor. We are deeply honored to have you with us.
It's my pleasure. You should know that half of my DNA is Spanish in origin, so I'm very proud of that.
Oh, really?
Yeah.
That's awesome to know. Well, yeah, while I was reading your book, there were a couple of things, were not just a lot of things that caught my attention, as well happened to be heartwarming for me in a sense. One of those things, is your approach to humbleness and having an open mind, like not only in science, but in your everyday life, which I thought that it was great. That is something I would like to talk with you in a moment, though. However, for now, I would like to start with what I thought of, as I said, was nice to read. You were born in Israel, and your father, as well your mother, were two figures that influenced yourself as a person throughout your early years and later on throughout your adolescence as well. It was nice to read that you would remember your father, an ingenious, smart handyman, always repairing, having solutions for things, and a tractor in which you drove yourself away in order to, have some quiet and read for hours alone. And on the other hand, you mentioned your mother as the source of inspiration, who was the person who actually first introduced you to the arts of philosophy.
Mhm.
It was surprising to me to know that if you could have done something else, you would have chosen the path of the thinker. And as I know, existentialism is a big thing for you, as I can recall, as your admiration for Sartre and Camus. In this sense, I would like to ask you about your opinion of philosophy and science. So, how does philosophy and science relate, and how important is philosophy for the development of the thought of for scientists?
Well, I think it's extremely important because philosophy asks the biggest questions we have and gives you a sense of the broader view. Whereas in science, very often scientists specialize in a very narrow niche and develop expertise so that they are the world expert on a particular subject. And that is very common today. There are very few Renaissance people, people that have broad interests. And the one thing that philosophy teaches you is that it's important to have the broad perspective. Let me illustrate that with an example. The dinosaurs, they had a narrow view of reality. They enjoyed eating grass. And you might say, well, they had a huge body, therefore they could survive for a long time, and they just ate their grass and were happy. Well, guess what? 66 million years ago, there was a big rock the size of Manhattan Island that became bigger on the sky. And when it hit the ground, it killed all the dinosaurs and 3/4 of all life forms on Earth. And the fun stopped at that point for the dinosaurs. Now, the humans have a much smaller body, but we have a brain. And we can design telescopes. And we can see rocks when they approach us. And therefore, we can, in principle, design a way of nudging them away from Earth, so that we will not face the same extinction as the dinosaurs faced. And so that tells you that having the broader view, rather than just eating grass or concentrating what happens to you locally, is an advantage. And let me give you another example. You might think that it's sufficient to just focus on the matters that happen within your home or even immediate neighborhood, and you don't need to read the news about the world. Well, guess what? Wuhan, China had an important impact on our lives everywhere, because something that started over there reached your doorstep and changed the way you live. And so unless you read the news about the world, you would be uncareful and you could be affected by the virus. So it's important to have information about the big picture and not just say, all I care about is a very narrow niche of reality. And that's very true, not just in our lives, but also in science, because if you don't have the broader view, you don't recognize that there might be something new that we discovered, or something new that we could discover. And when Albert Einstein developed his theory of gravity, he was influenced by philosophers like Ernest Mach, and because he needed a broader view. He changed the concepts about space and time and wanted to think about it more abstractly. So when you are designing a building, you have to work on the blueprint, and you need an architect view. I mean, of course, you can later on hire people that will do all the bricks and mortar work on making the building, but to design the building you need to have sort of an architect view, and that means a broader view. And so that's what philosophy brings to the table. It brings the broader view. I would go beyond philosophy. I would say the arts in general, the humanities, they give us a different way of looking at reality, a broader way, and it's different from what science does. And many scientists think that the humanities are not really needed, but I believe that they are very important. They play a very important role in our future. Just to give you a few more examples, for example, in the future there would be software operated by artificial intelligence that will make decisions about life and death, because it will replace doctors. And the question is, what do we need to, what should we allow artificial intelligence to decide in terms of medical procedures? Because human lives will be affected by that. That's a moral decision that philosophy should address. There would be issues with privacy. There would be other issues to do with how humans interact with technological equipment that will be very advanced. And so altogether, I think philosophy has, or genetic engineering, do we want to design people in some ways? And there would be major issues that would require the input from the humanities into the sciences. For me, it was very important to read philosophy books at an early age, because now at the later stage of my career, I'm able to look at things outside the box, because most of my contemporaries, that they are occupied with things that were known in the past, and they just continue to work on them. But I'm always interested in new frontiers, and I see the broader picture. So in answer to your question, I think it's extremely important to have a broad education. Of course, you can develop skills in a narrow niche, but the broader education gives you a better perspective about, the changing circumstances. So for example, reality offers you something new. If you don't have the broader perspective, you may miss that message.
Right. Yeah, and I'll let you address that issue that humanity might face in terms of having maybe artificial intelligence choosing between life or death. Right. I remember Professor Harari, the historian, actually writing about that, and I thought that it was quite conflicting in a moral sphere, in a moral sense, right? But we will see what happens with that in the future. Fortunately, it's going to be a good thing. But as I mentioned before, the second highlight that caught my attention in your book, aside from Oumuamua, of course, is your straightforward approach to being open-minded and always say humble enough. We all understand the concept of humbleness from a different spectrum. For example, I relate to humbleness to what I have been able to learn in sports, and then, of course, been able to transfer to my everyday life in regards to that. However, from your standpoint, how does humbleness relate to the sphere of the natural sciences, and why would you say that staying humble is important? And what does staying humble mean being a scientist?
Right. So, when I was younger, I mean, the message I got from studying astronomy was that we should be modest because the universe is so big and we are so small, and there are zeta planets in the like the Earth in the observable volume of the universe. That's 10 to the power 21 or so, and more than the number of grains of sand on all beaches on Earth. So how can you be arrogant if you accomplish something on one earth, the earth that we have? Even the most powerful emperors conquered just a small piece of the land on earth. And just think about it, it's similar to an ant hugging a single grain of sand on the landscape of a huge beach. But later in my life, over the past few years, both my parents passed away. And that sent me an even more important message. We live for such a short time, and we get a lot of satisfaction from honors, feeling superior relative to other people. This, to me, is a bit ridiculous, given the perspective that we are short-lived, and all of this will be eventually forgotten. We are really temporary. And to me, the realization is that we should be modest because, we are put in this world for such a short time. Let's focus on the substance. For me, the most interesting thing is to figure out what the world is, to figure out who else is on the stage and what is going on, what's the play about. And we are not so important, we are not playing a major role. It's obvious because the universe is so big. Of course, if we look just around us, we may play an important role, but that's just being narrow-minded. And then all of these ambitions that people have of, feeling superior relative to each other, they don't make any sense. And by the way, people do that not just based on accomplishments and sometimes based on very superficial things. Like if you think about racism, it's extremely superficial. Just the idea that a skin color or an ethnic origin makes a difference in the qualities that the person has. That's all meaningless. And when you think about the bigger picture, and so I find that humans are probably not very intelligent because they're preoccupied with these things. And that's why I look for intelligence from space. Perhaps there, we have a little more sophistication. But coming back to your question, I think it's in science, it's extremely important to be modest because what we know is so little. It's just an island in an ocean of ignorance. And we want to increase the landmass of this island by studying, by getting evidence on things in the world. But we should always keep in mind that there is so much we don't know. We should never be arrogant or proud of what we already know, because it's so little compared to what we don't know. Actually, as we learn things, we realize how much we don't know. And the way I see science is, in economics, there is this term zero-sum game, where if someone gains money, then other people lose it. And the total is, the sum is constant. So if someone wins, the other person loses, zero-sum game. Yes. However, in science, it's actually an infinite sum game. So if someone gains some knowledge, everyone benefits. So it's good for everyone to learn about the world. Nobody loses by one scientist gaining something. So that's why I find that science should promote collaboration, appreciation of each other. People should not ridicule each other, but rather say, okay, there is something unusual about this object. Let's figure out what it is. Let's work constructively to get more evidence and figure it out. One way to figure out is to take a photograph of this object. And by the way, in the future, if there will be another object similar to Oumuamua, the best way to figure out what it is to send a spacecraft that will take a photograph, a picture of it, because they say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book.
Sure. Professor, so let's just start talking about Oumuamua and directly about your book and what you just discovered. And I'd like to read just one sentence. I cut it a little bit, copyright. You said the object was traveling towards us from the direction of Vega. Mm-hmm. It intercepted the orbital plane on September 6, 2017. But the object's extreme hyperbolic trajectory guaranteed it would only visit, not stay. So, Professor Loeb, what is this object, Oumuamua, you describe in your book?
Mm-hmm. So this is the first object that we found near the Earth that came from outside the solar system, so-called interstellar. And we know that it came from outside the solar system because it moved too fast near the sun. So it couldn't be bound to the sun. You know, when we send a rocket away from Earth, if we give it a high enough boost and a high enough speed, it escapes the gravitational pull of the Earth. And Oumuamua was moving already very fast, so it escapes the gravitational pull of the sun. It came from outside the solar system. And of course, astronomers assumed, oh, maybe it's a rock, just like the rocks we have seen in the solar system before. And it just came from another star. The only problem is it didn't behave like any of the rocks we've seen before. It was not a comet because we didn't see any tail of gas or dust around it. And actually, the Spitzer Space Telescope looked very carefully around it, couldn't see any trace of carbon-based molecules or dust. And then it was reflecting sunlight. That's how we discovered it. And as it was tumbling, the amount of light that it reflected changed by a factor of 10. So just imagine a piece of paper tumbling in the wind, and the area of the object changed by a factor of 10 as we were looking at it. And it means that it's very extreme geometry. It has a very extreme shape because the piece of paper has a very small likelihood of being exactly edge on. So actually the best fit to the reflection of light from the Oumuamua as it was tumbling was that of a pancake shape, the flat object, which makes it again very unusual, very weird. Also, when it was moving, it was pushed away from the sun by some additional force. In addition to the force of gravity, there was an excess push away from the sun. And it could not be because of the evaporation of gas, because we didn't see any gas. It was not the rocket effect. So the only thing that can give it that push is reflection of sunlight. And for that to be effective, the object had to be thin, just like a sail on a boat, except that this sail was pushed by light. Mm-hmm. And nature doesn't make sails. If it was very thin, it should have been artificial in origin. In fact, just a few months ago, in September 2020, there was another object discovered by the same telescope, Pan-STARRS in Hawaii. And this one was also pushed away from the sun by reflecting sunlight and had no cometary tail. But the astronomers that discovered it realized that it actually came from the Earth. In 1966, it was a rocket booster from a lunar lander mission. And we know that it was hollow and its walls were very thin. That's why it had a lot of area for its weight. And that's why it showed the push away from the sun by reflecting sunlight. So we definitely know that this one was artificial because we produced it. However, we don't know who produced Oumuamua.
So how it's supposed to be the gravitational falling, if it would behave as a normal object? It should go directly to the sun, or?
No. So it was moving similar to an object that came from outer space and just was deflected by the sun. Actually, one other strange thing about it is there is a frame that is called the local standard of rest, which is the frame that you get to when you average over the motions of all the stars in the vicinity of the sun. Sort of like the local parking lot. And this object was at rest in that frame. Only 1 in 500 stars is so much at rest as this object was. It's sort of like a buoy on the surface of the ocean, and the solar system, like a giant ship, bumped into it. And so the way to think of this object is it was sitting at rest, and then the sun was moving in its direction and just gave it a kick through the gravitational force. So in that sense, this object, behaved just like any rock, except that there was an additional force acting on it in addition to gravity. And this one can be explained as reflection of sunlight that gave it an excess push away from the sun.
I think we're talking about Oumuamua, but also now I think the next step is, if we know there is intelligence out there, so we should trying to go there and actually trying to figure out if our hypotheses are real. And actually, going backward, The universe seems to share a common origin, a singularity, and basically from there all we know and we will discover in the cosmos share this initial matter of substance or moment of creation. You explain well in your book saying that following the Big Bang, matter was spread more or less evenly across the rapidly expanding universe. That it was spread almost uniformly is crucial. For in some places, we theorize the cosmos started out slightly denser than average, but those slight perturbations were insufficient. That was enough for gravity to start to pull the matter into this increasingly dense region and for clouds of gas. And in parentheses, it also made me think about, again, Dr. Krauss and the books, The Atom again, when he mentioned matter and antimatter and how a slightly difference between them in the really beginning, cumulatively, leads towards our universe. So my question is, what is the probability of being the only planet with life when it looks like the way our star and Earth were formed are not different than how other stars and planets were created as well? So if from the initial singularity and right after the Big Bang and all other things being equal, thinking that the Earth is the only one with life, it doesn't sound right, is it?
That's right, yes, because the conditions we have around us are replicated in so many other places. Now we know from the Kepler satellite that about half of all the stars that look like the sun have a planet the size of the Earth, roughly at the same separation. So not only that we are not at the center of the universe, like Aristotle argued, the ancient Greek philosopher, also our neighborhood is very common. The Earth-Sun system is replicated billions of times in the Milky Way galaxy alone. And, the Milky Way is one out of 1 trillion galaxies in the observable volume of the universe. So the conditions we have around us are not special, unique, or privileged. They exist everywhere. And that's why I think that, we are not unusual, we're not special, we're sort of typical, we're just like ants on a sidewalk. And that's why I think there should be civilizations out there. Maybe in the past, the sun is a relative latecomer. Most of the stars formed before the sun, billions of years. And these civilizations may have generated the equipment that they launched into space. And we can find some of these, just like plastic bottles on a beach. Most of the time you find the rocks on the beach, but every now and then a plastic bottle. And, in the past, we looked for radio signals. That would be equivalent to trying to have a conversation on the phone, and you need the counterpart to be alive when you have the conversation. But another approach, we cannot have a phone conversation, for example, with the Mayans. The Mayan culture is not around anymore, but we can find the relics that they left behind by doing archaeology. And in exactly the same way, we can do archaeology in space and search for relics of cultures, of civilizations that existed in the past. And I think that is the message from Oumuamua, that we should do space archaeology and basically send a camera every time we see something unusual, so that it intercepts the orbit of the trajectory of an unusual object, so that we can take a close-up photograph. Because I think a picture would tell us the difference between a natural rock and an artificial object. So evidence is really the key. And the only way we might not get the evidence is if the scientists would say, it's never aliens, it's always rocks. Because with a prejudice, we will never check. And it's just like what the philosophers did in the days of Galileo. They didn't want to look through Galileo's telescope. They knew for sure that the sun moves around the Earth, because the Earth was supposed to be at the center of the universe. And of course, the fact that they kept arguing that they didn't change reality. Reality doesn't care whether we ignore it. It just maintained their ignorance. And so I think the big lesson is for us to behave differently in the future and, search for other civilizations.
You just made me remember Giordano Bruno, who was burned because he think maybe could be hundreds of planets like the Earth, and he was sentenced to death. But I want to go one step back where you said finding frequencies on space would be having a conversation. But how we know that that conversation, that call, is not happening with a gangster of outer space? Well, how we know that all those aliens are good people?
Yeah, when you enter a room full of strangers, you better be quiet first, just listen and not speak, because you never know, there might be a predator that will risk your existence. And I completely agree with that. The only problem is we've been broadcasting radio waves for more than a century now, and they went out to a distance of more than 100 light years. And if there is any civilization with radio telescopes within that volume of space, then they know about us already. You know, we might hear back from them in several decades or centuries. I mean, it takes a long time to travel the distances, but we were not very careful until now. And I think we should be, as you mentioned.
Professor, I want to thank you for your time today. And I want to invite you, if you want, to come again and join us in a second opportunity. And it would be awesome for us, and I'm pretty sure our audience would be waiting and looking forward to hear you a second time. And probably next time we already discovered a second object.
So. Thank you so much. It was a great pleasure, and I'll be glad to speak with you again.
Thank you.